Hi JT, here's my video explaining my process for the exam 2. So here's the first question. That's how I set everything up. So it's 13 and 13, so the channel slope is 13 plus 13, 0.026. The floodplain slope is half of that, so it's 0.013. So then for part B, we're finding the Q at depth 6. So here's how I labeled everything. Here's how I split it up. These two parts are equal. And I split these two parts to make it easier for me to calculate, but then I just combine them together. So the area of 3, which is the trapezoid, 33 meters squared. The area of section 4 is 51 meters squared. 17 is the T up here. So it's just 17 times 3. I combine them, I get 84 meters squared for this entire area. So then for the perimeter, there's some erasing here because I made some mistakes. I counted like this line and this line and this line as part of the perimeter, which is wrong, and I'm happy I caught that. So then the perimeter for this section is just this line, and this line. So it's 5 plus the base plus 2 of these sides. The side is 6.71. I calculated that by making a triangle here. And that's 18.42 meters. So then the R is the area, total area, over the perimeter, the total perimeter, so it's 4.56. And then I found the Q, plugged everything in. The Q for section 3 and 4 is 1,843.66 meters cubed per second. So then area 1 and area 2, these are the exact same thing, so you can set them equal to each other. So the area is 1/2 the base, which I said base is 3. If the base is 3 and the M is 3, that means the height is 9. So 1/2 base times height is 13.5 for both of them. The perimeter, I also thought this line and this line were part of the perimeter, which they're not. So it's just this line right here. So it's square root of 3 squared plus 9 squared to get that hypotenuse right there. So that's 9.49 meters. R is just area over perimeter, 1.42. And I found the Q for 1 and 2, which is 48.13 meters cubed per second. And then for the entire thing, I combine them. So it's the Q of section 3 and 4 plus 2 of one of these sections. So it combines them. So it's the total Q is 1,939.92 meters cubed per second. So for the second question, question 4, here's how I set it up. So to find T, this equation, 5 plus 4yc, the area, that equation, plug that in, set it equal to 1, we get this equation, and then we can get the critical depth, which is 1.16 meters. Now we have to find the area at the critical depth, so you just take this equation, plug the critical depth into the YC, and you get 8.5 meters squared. And then you get the energy equation, so you do the static energy plus, I think, the kinetic energy. And you get the total energy, so it's 1.6 for the energy. So then part B, we're finding whether a depth of 1 meter is supercritical or subcritical. So we just take these equations up here, and you just plug in 1 for the YC, so you can get T equals 9 up here. And then A, the area is also 9 meters squared. Plug those into the Fruit equation. We get FR equals 2.66, and that's greater than 1, so it's supercritical. And then for the alternate depth, I used the energy equation and plug that in for Y equals 1 meter. That's the energy, so then we got to find the same energy at a different Y. So you set it equal to this, 1.65, and then you're finding a different Y value. So the Y value that has the same energy as Y equals 1 is Y equals 1.36 meters. So then for the last problem, question 5, for critical depth and normal depth, I used an Excel solver. So here's on my computer, here's my Excel. This is for the critical depth. I use the same file for critical and normal. These are my numbers for the critical depth. I'll include screenshots when I submit my test for those. So we did those using the solver, and then we found out that the yn is less than yc, so that would mean it's a steep slope. And then y equals 4, so that's zone 1, so that means the classification is S1. For part B, we're doing the water surface slope. So the area at a height of 4 meters, 24. The perimeter, 20 meters. And then we set up the equation to find SF. We get a value of 0.00014. And we use the fruit equation. We get this value, 0.0277. And then we can use these two numbers to plug in this equation. And this equation is we're finding the slope. So that's the slope right here of my drawing. So we're trying to find the distance between 4 meters and 4.5 meters height. We're trying to find the x. The length between these two, where 4 meters would go to 4.5. Here's my equation I set up, and x, the length, should be 49.50 meters using this method. So then for part C, we're using the direct step method. So area, perimeter, R, we've got to find V, which is just Q over A, and then we find the SF. So we find the SF value by using this equation. I got 0.000144, and that's at y equals 4 meters. So then we're also finding it at y equals 4.5, because that's the two y's, so we're doing the same exact thing, but using 4.5 this time. So we get SF2, same equation, and we get 0.000104. Take both of these SF values, average them together to get 0.000124. And then we're using the delta L integration method right here. So here's the equation I set up. This is the y2, this is the y1, and then we get 49.51 meters, which is good because my other answer was 49.50 meters, so they're very, very close to each other, which is what I wanted to get. And then for part D, I said my distance on part B is 49.5 meters, and for part C, my distance is 49.5. So they're very similar, but I believe that part C would be more accurate because it's using the average slope over the entire thing instead of one slope. So I believe that would be more accurate. All right, thank you, JT. That's my explanation.